Hey all you cool cats and kittens. Today we are going to start with our trigonometry unit. I hope you guys had a wonderful spring break. This is a pretty in-depth unit. I know you probably started it with Mr. Sawyer last year, just looking into some of trigonometry, which is sine, cosine, tangent. Really, we're going to just say it's SOHCAHTOA from now on. But it's really in-depth pretty quickly. So if you have any questions, make sure you're asking them and emailing me because I know there's a lot to this. So we're going to present because we're going to take some notes today. And here we go. So trig functions. There are 3 trig functions found on your calculator. And I have my calculator here. I also had a calculator, let me get it up here, shared with you guys. This is the calculator right here. You're welcome to either use a graphing calculator or this. The reason we're not using Desmos right now is Desmos is always in radians because higher math generally uses radians. So we want to use degrees right now, hence why I gave you this calculator. So if you're using the calculator on the screen, use degrees. If you are using this calculator right here, you're going to have to put it into degrees mode. So I have to turn it on first. And then I'm going to press mode at the top right next to second. And if you can see radian is highlighted, we need to put it in degree mode. All right, so there are 3 different trig functions on here. There's sine, cosine, and tangent. And whenever you do it on the computer, you can generally just abbreviate those as sin, cos, tan as they're abbreviated on here, and you can just type it in. So these trig functions help us solve for missing angle measures or side lengths of a right triangle. Make sure your calculator is in degree mode, which we already did. So the first one is evaluate sine 78. So if you're in this calculator, you would just put in sine 78, and then you press enter. We're going to round to the nearest 10,000th, which is 4 decimal places. So this is 0.9781. So this is equal to 0.9781. Now, if you were on this one, you would do the same thing. You can type it in, or you can actually click the sign here. And then it's sine 78. And you have to finish off the parentheses to get it actually correct. And as you can see on your screen, right under where it says calculator, it says 0.9781. So we did it that way. I am going to just use the TI from here on out, but if you're using the other one, it gives you the same answer. The next one is cosine 78, and we get 0.2079. And again, as you do this in the computer one, you have to make sure you end the parentheses. On this calculator, you don't have to end parentheses. And last one is tangent, or tan 78. And that's going to give you 4.7046. So 4.07, if I can type it correctly, 7046. So at this point, pause the video, you try and do the next 3. Here we would have sine, we're starting out with cosine, cosine 45, and we get 0.7071. And this is actually a special one we'll talk about tomorrow. Sine 45, because sine is going to be the exact same, 0.7071. You'll eventually know these by heart, some of the special ones. And then tangent 45 is 1, as you guys can see there. Okay, so there are 3 main trig functions, and those trig functions are, we can remember them from SOHCAHTOA. SOHCAHTOA. My last class used to say SOHCAHTOA. That helps you remember it that way. So it's sine is opposite over hypotenuse. Opposite over hypotenuse. Or O over H. Now, the opposite is the opposite side length across from the angle. So we always go across from the angle for opposite. Hypotenuse is always across from the 90-degree angle. And then the adjacent is next to the angle, not including the hypotenuse. So hypotenuse across from 90-degree angle. That's the main one you have to remember. And then opposite across from the angle. Another way to remember adjacent is adjacent's always going to be between the angle and the 90 degrees. So that also might help you. Now, cosecant is the reciprocal. So all of these are reciprocal functions, and that means reciprocal functions, and that's when you flip the top and the bottom. So cosecant would be h over o, or hypotenuse over opposite. If you want to write it all out, you're more than welcome to. Cosine, the ca in SOHCAHTOA, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Or a over h, which means secant, the reciprocal of cosine, is h over a. Now, I know this is a little confusing because wouldn't cosecant go with cosine? It would make sense if they did that, but cosecant goes with sine and secant goes with cosine. I have no idea why that works out the way it does. And then lastly, tangent, that's the TOA part of this, is opposite over adjacent. O over A. And then cotangent would be A over O. But if you remember SOHCAHTOA, you should remember everything else. Now, on here, we don't necessarily have secant, cosecant, cotangent, but if you were to do 1 over sine, whatever, you would get the same answer because that's doing the reciprocal of it. So you can also do that. All right, example 2. Find the indicated trigonometric ratio as a fraction and as a decimal. We're just going to do the fraction, but we are rounding to the nearest 10,000ths whenever we're doing decimal. So we need sine of m. So angle m is right here. Sine is opposite, which is 16, over hypotenuse, and the hypotenuse is 34. Now, I'm not going to label those right now because we might be switching some stuff around, but remember, opposite of m is 16, hypotenuse is 34 because it's across from the 90 degrees. Now, if we reduce this, we get 8 over 17. You should always reduce. All right, tangent of L. So L's right here, and tangent is opposite, which is 30, over adjacent, which is 16, because this is between the angle and 90 degrees. So that's 16. And if we were to reduce this, this would be 15 over 8. Cosine L. Cosine, so here's L. Cosine is adjacent over hypotenuse. Adjacent is 16 over hypotenuse of 34. And you would get 8 over 17. That's the same as sine M, but cosine L, because we're starting from a different angle, we would still use those numbers. Okay, I want you guys to try 2, 4, and 6 before I do it, but if you want to go with me, you're more than welcome to. So cosecant of z, here's z. Cosecant is hypotenuse over opposite, so hypotenuse is 20 over the opposite of 16, which would give you 5/4 when you reduce. Secant, oh goodness gracious, I might have done that wrong. Cosecant, no, I did that right. Secant of x. Secant of x, so x is here. Secant is hypotenuse over adjacent. So hypotenuse is 20 over adjacent. Here's x right here. The adjacent is right here, 16. So that is also 5/4. And then cotangent of z. So z is here. And cotangent is adjacent, which is 12, over opposite, which is 16. This reduces to 3/4. So the big thing is knowing where your angles are. If you like to put O, H, and A down, you're more than welcome to for any of these. Okay, so here is my theta right here for this next one. This is theta. And it tells me secant right here. So secant, remember, is H over A. And my secant, so my hypotenuse is 5. and my adjacent is 4, which means I need to find this right here. Now, when we're missing a side and it's a right triangle, there's a specific theorem we can use. And that theorem is called the Pythagorean theorem. This is something you probably learned originally in 8th grade or 7th grade, and you might have used it a couple times since then. So here it's a squared plus b squared equals c squared, where c is your hypotenuse. In this sense, it's 5. So we would have 4 squared plus b squared equals 5 squared, or 16 plus b squared equals 25, meaning b squared equals 9 and b equals 3, because you take the square root of both of these. That means this right here is 3. And that's how you find the missing side of a right triangle. So now that we have that, we can fill in the rest of these. Before I go on, because I know it might help some of us, we're going to identify opposite, adjacent, and hypotenuse since the angle is not changing. The theta is not changing. So the opposite of theta is 3. And as you can see for theta, we put a little line through it. I know it kind of looks like 0. It gets a little confusing, but we should be okay. I try not to make the line go outside of the 0, or the circle. Didn't do so great on this one. Hypotenuse is always across from the 90 degrees, and the adjacent's between the 90 degrees and the angle. So now that we have that, sine, or SO in SOHCAHTOA, is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, the easiest way to do these three is just to flip those. You can go back and do hypotenuse over opposite and go through them all, or you can just say these are the reciprocals. So we are going to flip them. And that is how you do the reciprocal functions. Okay, let's keep going on. So along with finding angles, we can find sides that are missing. Or sorry, we can find an angle measure if we have the sides. If we're given a trig decimal, we just use the inverse trig function, second trig function, decimal. So here, find the missing angle measure. So it says cosine A of 0.7431. So in here, you would do the inverse of cosine, which is second cosine, and it says cosine to the -1. So essentially what we're doing is we have to do the inverse on both sides to get A by itself, which would give us something like this. So we're going to put in the decimal, 0.7431, and we're going to get an answer, which we're going to round to the nearest ten thousandth again, so four decimals, 42.0038. And remember, we're in degrees, so it's 42.0038 degrees. And that is your answer right there. In here, we would need to press the invert button down here, and you could do the same thing. So cosine, it's sometimes called arc sine, arc cosine. So in here it's spelled as ACOS. That means arc, and arc just means the inverse. We did 0.7431 and the parentheses, and it gives us the same exact answer. So either way is fine. It's just up to you. So I'm going to continue to use this calculator so you guys can see it in real time. And the next one is inverse of sine, or arc sine, of 0.4848. And then this is 28.9994. So 28.9994 when you round correctly. And remember, we're in degrees. The next one is arc tangent, or the inverse of tangent, of 0.5317. And this one is going to give you 27.9996. Now, roughly, this is probably going to be 28 degrees. This one's probably going to be 29 degrees. And this one's probably going to be 42 degrees. It's almost definitely because we rounded here. So in an answer choice, you might have the answer 42 degrees. And that is totally fine. We're just going to go to 4 decimal places right now just to be sure. All right, now you're going to try A, B, and C by yourself, so pause the video before you go on. All right, for A, you should have gotten 25.0420. Trying to remember my wonderful rounding rules. The next one you should have gotten 34.8350. And we are going to officially write these normally as angle Q equals angle G equals, this is angle A equals, just so we can remember what this looks like in official math language. So this one's going to be angle R equals, let's put that one in there, inverse sine 0.6932. I need to actually put the decimal in there, and I get, I put a negative, I shouldn't have put a negative, 0.6932, 43.8840 degrees. All right, so now it's asking us to find the missing angle measure. So just like we did, but now it's giving it to us in a different way. All right, so 18, because this is the 90 degrees right here, is your hypotenuse. And 9, because it's between the two angles, is your adjacent. Since we have adjacent and hypotenuse, we're using cosine. So it's going to be cosine of A is equal to 9 over 18. Now we actually have to find that out. So we do the inverse cosine. So angle A is equal to inverse cosine, and 9 over 18 is 0.5, and you get 60 degrees. Okay. Likewise over here, across from y right here is opposite, and this is hypotenuse. So opposite and hypotenuse is sine y is equal to 2 over 15, not 18, which means angle y is equal to inverse sine 2 divided by 15, 7.6623. 7.6623. That's a pretty small angle. Remember your degree sign. Okay. If you guys feel like you have this, please keep going, but this is a little bit new right here. So looking at this right now, we have an angle, we have an opposite side, and we have a hypotenuse, which means we're doing sine. Now sine of 30, because that's the degrees, you always take the degrees, always goes with the trig function, is equal to x over 15. So to solve this, we would multiply both sides by 15, which means x is equal to 15 times sine 30. 15 sine 30, or 7.5. And that is your answer. So for the next one, here's your angle right now. Here, this across from it is the opposite. This right here is the adjacent because it's between the two angles. So we have tangent here. Tangent of 43 degrees is equal to opposite, which is A, over adjacent, which is 11. So let's look at this. Let's multiply both sides by 11, and we get 11 tan 43 is equal to 10.2577. So A is equal to 10.2577. Now, one thing I want you to notice here is a lot of times they're going to use A, B, C for a triangle. The angles are going to be named with the large letters, so the uppercase letters, and then the side that's across from the angle is going to use the lowercase letters. So since this is big A, this is going to be little a, this is big B, this side would be little c, and this is big C, so this side would be little c. That's generally how you're going to see triangles in upper math. Okay, for the last one, we have an adjacent, we have a hypotenuse, so HA, we're using cosine of 21.8 is equal to A over 5.39, multiply by size by 5.39, and we get 5.39 cosine 21.8, and it's 5.0045. A is equal to 5.0045. All right, now you guys are going to try A, B, and C from the next one yourselves. If you need some help, I'm here, so don't worry, I'm going to keep doing them. But really, I think you guys can do this. It's really just remembering your ratios. So for this one, here's our angle. We have a hypotenuse and adjacent. This is cosine. Again, try and do this yourself before I do it. A over 83. And we get 75 well, that's a big one, 75.2235. Now, one thing I do, especially if it's my first time answering one of these, is I always check to see if that makes sense. So one thing, when I looked at that and I was like, that's a really big number for a side, I went back and I looked at my other side, it's 83. That's not too crazy to have a side then that's 75. But I was like, whew, we got to look at what our other side was to double check that this makes sense. All right, for this one, I have an opposite and a hypotenuse. So we have sine of 45 is equal to 35 over h. Now, when you have something like this, you guys can just flip these two, because essentially this is over 1. We're going to cross multiply, but you can just flip these two. So it would be the same as saying h is equal to 35 over sine 45. I'll show you the math for that really quickly, why it works out, so that later on, you can just flip them. But if I had sine 45, as you can see, I had some other math on here, equals 35 over h. We can put this over 1 and cross multiply, and we get h times sine 45 is equal to 35. We divide by sine 45 to get h by itself, and we get h is equal to 35 over sine 45. So it's easier just to know that you can flip those two if need be. So we're going to put that in here. 35 divided by sine 45 is equal to 49.4975. So x is equal to 49.4975. And if instead of x you put h, it's still okay. And for the last one, we have a, this is the angle right here, this is the 90, so adjacent, and then opposite, so we're doing tangent of 55 is equal to 29 over x. You can also always do cotangent for this if you don't want to do the flip like this. I generally do not use the reciprocal functions. I can't really think of a reason to use the reciprocal functions because these work out just as well. So x is equal to 29 over tan 55. You only really use the reciprocal functions if you don't want to do this math right here. 29 divided by tan 55 is equal to 20.3060. Okay. That is all I have for you guys today. So you guys have an activity to do today. I know you're going to be great at it. If you have any questions, please make sure you're asking as needed. And I hope you just have a wonderful day. Bye.